G'day there. In this video I'd like to show my 2Pancake 2 transistor wireless dual thief in an interesting mode. It's currently doing an on off every few seconds thing as this 9-volt battery here goes flat and then self recovers. I did want to drain it out to zero for reconditioning, so I left it running overnight just to see how it'd go in the morning. And as we can see here, this is the voltage in our battery. It drops down and then builds back up. And then it'll drop down again about an hour. There we go. And what's actually going on here, see if I can get the scope and the multimeter in the shot for you. The voltage builds up until it can switch it on, and then drains the battery down, and then runs out of juice and turns the circuit off and has to build the voltage back up again. And this is happening quite a few times a minute. So I thought, wonder how much amperage is actually coming out of that battery. So I've got this little meter here set to amps and ready to hook up. Just move this probe here. I would like to point out though, why isn't that working now? There we go. That the meter does actually interfere with the system, depending on what setting I have it on. At the moment it's on the 200 milliamp setting. And it's not showing the most accurate readings there. It shows that we go up to about a milliamp of draw, or just under, every time it switches on, and then drops back down again. I wanted to get a better idea of the microamps, because obviously that's where it's running most of the time. And it still does much the same thing in that mode, which is the 20 milliamps range. But when we switch around into microamps, it doesn't do it so much. It sort of just keeps running. And that's a classic example of the meter interfering with the system. I'm not sure if we'll see it, but this little LED will light up at times when the system starts. There we go. So it is working. That's a wireless receiver wedged between the 2Pancakes. And it's getting as strong a signal as it possibly can in there. It is working. And again, this is both of the bases. I believe the blue line is the PNP base and the yellow line is the NPN base. And I think they're going faster than what my scope can read. Those waveforms look pretty funny to me. I think I'm looking at a harmonic. That is the fastest setting for my scope, at 0.1 of a microsecond per division. I can't go any faster than that, so I think that's a harmonic that I'm looking at, and that it's actually in the megahertz range. And over here I know my frequency counter tells big fat lies all the time. The number will be correct, the degree of magnitude will be wrong. So if that's saying 1.1 kilohertz, as it is, I'm probably looking at well over a megahertz, which is getting well outside the analog bandwidth of this scope. But anyway, I just thought that's an interesting little phenomenon of the flashing triggered by the battery recovery. And that I'd also take the opportunity to demonstrate that amp meters in series with the circuit, particularly these simple blocking oscillators, will often change the way the circuit runs quite dramatically. Because you're putting a resistor in series with the circuit. So look at that, it's not running nearly so low now. It's slowed everything down. We're no longer switching on and off. It's slowed the amp draw down so much that the battery can continue to run the circuit and regenerate itself. Voltage and amp draw are both now coming up. The oscillations have changed their frequency and magnitude. You notice my PNP transistor's not firing to anywhere near the same magnitude now. If I switch that meter back, look at that. It changes my waveform every time. I've just switched back to the 20 milliamps, 2000 micros when it comes back. Waiting for some battery recovery. There it is. And that is the 200 microamps range on that little tiny baby meter. Okay, so there you can see that just measuring the amps of one of these circuits can actually cause all sorts of tuning dramas. It totally alters the way the circuit runs because you are changing the input voltage or the input current. Either way, you are putting a resistor. I prefer to often measure, for this reason I often measure on the negative side of a circuit, but it doesn't affect the voltage drop so much, but it still brings up the negative voltage at the other end of the circuit, so it's still doing much the same thing. It still limits the current. So taking measurements on a blocking oscillator with an in-series multimeter gives you a ballpark idea at best. Often totally changes the way the circuit runs and throws all your readings completely out of whack. But I mostly just want to show you the way this battery recovers and then pulsates the whole circuit because I think that's really cool. Anyway, thanks for watching.